Okay, geometry, we're just running a little bit of a test right now. We're trying to figure out if this is going to work out well for our purposes here or not. So I'm going to actually begin the notes on section 1.2, but this is not going to be a real long one, and we're not going to finish that entire section. I just want to see if I know how Loom works and if the audio and video are working okay. So most sections I'm planning on starting with a little bit of an introduction like this, where I get to say hi to you guys. I'm here in my classroom, E212, smartboard here behind me. But we're going to see how this works. Okay, so I'm going to switch on over now to our Smart Notebook software. And in this spot, this is where we're actually going to start taking our notes. Now, if I understand this correctly, you guys can still hear me, but can no longer see me. And we should be able to walk through here and get a little bit done going on in our notes right here. So we're going to begin with section 1.2. It's a little bit odd that we skipped chapter 1, section 1, but the book decided to start with something that we felt would be better covered a little bit later on in the year. So 1.2 deals with what we call the building blocks of geometry, the three basic undefined terms that everything else in geometry is going to be built off of. And those three undefined terms start off with this concept right here of a point. And trying to be consistent in our notes, we're going to go through three things. We're going to start to try to come up with a definition of a point, which is odd because we just called it an undefined term, but we'll do the best that we can, talk about how to name it, and then how to draw it. And we'll do that with each of these three terms. So when we talk about a point is by far the simplest in the geometric universe, everybody. And our working definition of point is going to be a single location in space. A single location in space. So a point is essentially the smallest and simplest thing that we can get in geometry. And it's not until you start putting points together in various ways that all of a sudden they form something. But a point is just where one particular thing is located. A point is named, everybody, with a single capital letter. A single capital letter is how we are going to name a point. So for example, we might call, switch to red right here, we might call a point A. And if you ever see just that single capital letter, like that A right there, you don't need to write the word point in front of it because it is understood in geometry that the only thing we name with a single capital letter is a point. So A could be a point. P is a common letter that we use for point, obviously, because it starts with P. And of course, X, Y, and Z are some of our favorites to use as well. So those would be examples there. But of course, with 26 different letters in the alphabet that we use, we get to use 26 different names for points there. And as far as a diagram, boy, this isn't much of a diagram. It's going to be one of the simpler things you see. When we draw a point, we simply make a little dot like this here, and we would put the name of that point right underneath it, or above it, or next to it. So I'm going to call that one right there point M. Now, one thing that we should point out is when we drew this dot right here, we obviously had to draw it big enough so that we could see it. Otherwise, what would be the point? But it's important to understand that what I just drew right there isn't technically correct. What I drew there has a size to it, and a point is so infinitesimally small, there's a fancy geometric word for you, that it actually doesn't take up any size and it doesn't have any area. So that's an important thing to note that we might want to add right here to our definition of a point. So I'll kind of come sideways with this one, and we might write here that a point has no size or area. So we have to draw it bigger than it is, otherwise we wouldn't be able to see it. Okay, the second undefined term of geometry is a line, and this is one that we're going to see quite a bit here. Now, the definition of a line is a little bit wordy, guys, but it is this. It is a set of, and I hate to use this word here already, of collinear points. Now, the word collinear we're going to define here pretty soon, but collinear, if you break it down, the co means with or together, and linear, you'll notice, contains the word line. So collinear points are points that are all on the same line. So our definition of line is a set of collinear points extending infinitely. That's important there, everybody. It does not end, but it extends infinitely in either direction. And we've got to be careful to read the word either correctly here. It really means in both. So a line is a set of points that all are in line with one another. They're collinear, and it goes on forever. That's what infinitely means, in both directions. We like to think of that as left and right, but it could be up and down, and it could be diagonal as well. A line is named, this is important now, by any 2 points on the line. By any 2 points on the line. And so we're going to use a diagram right here and then talk about how to name what we just came up with here, guys. So if we wanted to draw a line, here's probably the simplest way that we would do it. We would choose 1 point right here, which I'm going to call point A, another point in a separate location, which I am going to call point B. And now what we're going to do is draw the one and only line that passes through both point A and point B. And to show that it goes on forever in both directions, we would put arrows at the end here. And what we've just drawn now here, everybody, is line AB. And the notation that we use, this is important, and we're going to use it all year long. The notation that we're going to be using in geometry for a line is name it with the 2 points, capital A, capital B, and then draw a line going over the top of it. So what we have right here, everybody, is line AB. It is also completely okay to name the line backwards. There's no rule that says that you have to name it from left to right. So we could also call this line BA, and that would be perfectly fine as well. And here's where things get really interesting. If I were to ask the question right now, how many points are located on that line, almost all of us are going to look at that and say 2. Point A and point B. But one of the important things that we need to get used to in geometry is the idea that just because something isn't labeled doesn't mean that it's not there. There are more points on this line than just A and B. So if I were to switch to red and say, okay, right about there, there's a third point that I'm going to call point C. Well, now we've got 3 that are located there. And guess what? There's another point out here somewhere, and we'll call that one point D. And there's another point over here somewhere called E. And we could sit here all day long and continue to identify and name other points that are on this same line right here. And so the answer to the question, how many points are located on a line? It's a big number. In fact, it's infinite, meaning something that is so vast and so big that it cannot be counted or measured. There are an infinite number of points that are collinear with A and B and therefore on the same line. And so the fun thing now is when we name a line here, everybody, by any 2 points located on that line, that means that there's a lot of different ways that we could name this thing. Not just AB or BA, but we could also name this, for example, we could name this line EC, because those are 2 points that are on that line. We could name this line DB, because those are 2 points that are on this line. We could name it EA, because those are 2 points that are on that line. With 5 points that we've identified, we actually have 20 different ways of naming this line here. 5 options for your first point, and then 4 remaining for the second. All right, so that's how you draw a line, and that's how you name a line. It's one of the most versatile things in geometry. We can do a lot of things with it, and we can name it a lot of different ways. Okay, and the third undefined term of geometry is the toughest one usually for people to get the hang of, and that is a plane. Okay, and the definition of a plane, now we're starting to expand our thinking a little bit more, but a definition of a plane here is going to be a flat surface. Let's go with that for now, guys, as kind of a functional definition. A flat surface, and this is important here, guys, to understand that a plane is 2-dimensional as opposed to 3-dimensional. So it's a flat surface that extends infinitely, there's that word showing up yet again here, infinitely in, and on a line, we said infinitely in both directions, both implying 2, but a plane goes in more than 2 directions. So we are going to say extending infinitely in all directions. And depending on how you situate or orient your plane here, you might think about that as front to back and left to right. But if it was a vertical plane going up and down like a wall or the smartboard that I'm writing on right now, you might think about extending left and right, but also up and down. Okay, naming a plane can be interesting here, guys. A plane is named by using any three, and this is important now, non-collinear points. So any three non-collinear points in the plane. And we'll see what that looks like in just a second. And then for the diagram on a plane, this is where things get a little bit interesting here, guys. There are many, many different ways of drawing a plane. And usually the simplest way to do it is to talk about a plane within a larger diagram. Like if we were to draw a shoebox, that's got 6 different planes that make it up. But when we draw a plane all by itself, what mathematicians around the world and who write lots of different textbooks will normally do is draw a shape that I'm hoping you guys recognize from a previous math class. We usually tend to draw this 4-sided figure here, which is kind of a slanty rectangle, otherwise known as a parallelogram. And within that parallelogram, we've got this flat surface, and if we want to name it, we just need to identify and name 3 non-collinear points in the plane. So what we would probably do here is just pick a random point there and call that Z, some other point somewhere else and call that Y, and I just need to make sure that for my third point, which I'm going to call X, I just need to make sure that point X is not on this line here that connects Z and Y. If I were to put X right here, those 3 points would be collinear, and that is not what we want. So I'm going to get rid of all of that, and I'm going to put point X just somewhere else over here to the side. And the simplest way to do this now would be to look at this figure here and call it plane, and the order of the letters does not matter, you guys. So I'm going to just go with plane ZYX, and that's a proper way of naming this plane. But let's be careful. There aren't just 3 points in this plane. There's actually an infinite number. So if I were to choose a 4th point over here and call that point W, that now means that I can choose any 3 non-collinear points in any order that I want and name the plane that way. So I could call this plane YZW, and that works because there's 3 non-collinear points there that make that up. Now, the tricky thing about a plane, let me go back to this definition right here that we had up above, guys. The definition of a plane is a flat surface that's 2-dimensional that extends infinitely in all directions. The biggest problem we have with the way that just about everybody draws a plane is that if we think of it as a parallelogram, the problem is that it ends. The parallelogram has borders, and those are the 4 blue line segments that we drew around the outside. If Mr. Fontana were in charge of the world, which I'm not, I would actually draw a plane this way, and I would make you guys extend and put arrows at each end of these lines that we drew here. And the arrows would indicate, and I was hoping people would understand that this thing goes on forever. So the weird thing about this is, and this is where it can get difficult to draw a plane properly, if I were to ask you guys, is point J inside the same plane as W and X and Y and Z, everybody's going to look at this and say that yes, it is. And the way it's drawn, they're probably correct. But the interesting question comes if I come over here and put point K over there. And I ask you guys, is point K in the same plane as the other 5 points? Well, at first, most people are going to look at that and they're going to answer that question no, because they see K hovering over here and they say it's outside of the plane. But the mistake in their thinking there is thinking that the plane ends, that this is the boundary of that plane. But we actually need to remember that a plane extends infinitely in all directions. So think about the surface of your desk, but a desk that was infinite in size and just kept going on forever. Point K would be contained within that. So it's actually really, really difficult to draw points that are non-coplanar, and we've got to use some tricks of geometry and isometric drawings in order to show that, but we're going to get to that a little bit later. All right, everybody, that's as far as I wanted to go for this part of the video. I'll come back a little bit later and we'll wrap up the rest of the notes on section 1.2.